In the previous session, we learned how to classify and mark the traffic. But here's the real question. What happens when all the traffic still exceeds the available bandwidth? Do we drop it or control it intelligently? Because in real networks, marking alone is not enough. And that's exactly what we are going to discuss in this session. Welcome back to the CCNP ENCOR course 350401. After classification and marking, the next step in QoS is traffic treatment. This includes policing, shaping, queuing, and dropping decisions. So in this video, we'll focus on traffic policing and traffic shaping. In modern networks, bandwidth is always limited, but not all applications are the same. Some applications are highly sensitive to delay and performance, such as voice, which requires low latency and minimal jitter, whereas video requires consistent delivery and smooth playback. So data application can tolerate delays but still need some reliability. And because of these differences, we cannot treat all traffic equally. So even after marking, when traffic exceeds the available bandwidth, we must control it. This is where policing and shaping comes into the picture. Both policing and shaping detect when traffic exceeds a defined rate, but the difference lies in how they respond. Let's look at both of them. Traffic policing makes an immediate decision. If traffic exceeds the defined rate, it drops the packet or remark to lower priority. Whereas there is no buffering and packets are handled instantly. And if you look at traffic shaping, it uses buffering. Instead of dropping packet, it delays it and smooths the traffic flow and ensures traffic stays within the limit rate or within the allowed rate. You can think of it this way. Policing protects the network, whereas shaping protects the traffic. Let me try to explain this with a simple analogy. You can think of a road traffic. In policing, the police turns car away when the road is full, whereas shaping makes car wait and release them gradually. Now let's move from concept to real deployment. Now let's see where we use them in our networks. If you look at traffic policing, it is applied at the network edge on incoming traffic. If the traffic exceeds the rate, it is dropped before entering the network. As you can see in the graph, as soon as it crosses that barrier, it drops. This helps in protecting the core bandwidth and prevent unnecessary congestion. But dropping packets can cause TCP retransmissions. Let's see where we apply traffic shaping. Traffic shaping is applied on egress interfaces, especially towards the service provider facing interfaces, where you connect your network to the service provider. And instead of dropping the packet, here we control the rate before sending it out. This ensures we stay within the SLA limits defined by the service provider. The provider does not drop our traffic, and this results in fewer packet drops and better TCP performance. In simple terms, I would say policing controls incoming traffic and shaping controls outgoing traffic. Now we have seen where we apply policing and shaping or where it is used. But how do they actually control the traffic under the hood? What decides whether the packet is dropped or delayed? This is where the token bucket algorithm comes in. Both mechanisms rely on token bucket algorithm, and the idea is simple. Tokens are added at a fixed rate. Each packet needs token to pass, and if the token is available, send it. If the tokens are not available, then either apply policing by dropping the packets or apply shaping by making it wait and smooth it. This is the foundation behind both the mechanism. Now here it is where the things get interesting. To truly understand policing and shaping, you need to understand the parameters that control them, because in real network, these values define how traffic is actually handled. Let's break them down, starting with CIR, also known as Committed Information Rate. This is the policed rate, and this is the guaranteed average rate allowed for traffic. Next we have PIR, also known as Peak Information Rate. This is the maximum rate traffic can reach temporarily. PIR is the guaranteed average rate allowed for traffic, CIR, whereas PIR is the peak information rate, the maximum rate that can be applied, that can reach temporarily. The next one is BC, also known as burst size. This is the amount of data allowed to be sent at once without being penalized. Like if you see the graph, at a time there will be burst of data, right? So that is BC. And then we have TC, also known as time interval, the time window over which the rate is measured, especially in milliseconds. And the formula for calculating the TC is BC divided by CIR into 1000. So this will give the actual TC. So these are the building blocks behind traffic control, and together these values decide how strict or flexible your traffic control will be. Now let's take one step deeper. As you know, not all traffic is treated the same. So policers can classify traffic based on different levels. So there are different policing algorithms, including such as single rate 2 color marker or policer, single rate 3 color marker or policer, or 2 rate 3 color marker or policer. Let's start with single rate 2 color marker or policer. I will not go into detail. I will just give you a brief understanding of what it is. The single rate 2 color marker policer uses only one CIR. If you see, there is a dashed line and there is a CIR. Left side is policer, like marking down the traffic which exceeds, and the right side is the one dropping one. So if you see, it uses only one CIR, and traffic is either, as I said, confirm within the CIR allowed, or exceed above CIR, dropped or remarked. Then we have single rate 3 color policer marker. The idea here is use one CIR again, and then add 2 burst level, like BC plus BE. Let me write it down and show you. Just give me a second. Okay. So if you see, there are 2 levels, okay? BC. Within the BC, traffic is safe. For example, this is the BC below this. And then we have BE, which gives you the warning, like if it falls under the BCBE, the traffic will go, but still there will be warning. So as I said, like traffic becomes safe within the BC, and between BC and BE, it will be like there will be a warning generated. Then we have 2 rate 3 color police marker or policer. Here it uses 2 rates, as we discussed in key terms. If you see, this is PIR and this is CIR. It uses 2 rates. Traffic within the CIR, no issues, like it will pass. And traffic between the CIR and PIR, like it's like a warning. And then traffic above PIR, it will drop or mark down. So these are the three different policer types you can use. We'll see about it more when we do the lab. So to summarize, I would say in this video we discuss QoS traffic control ensures efficient bandwidth usage, and policing drop excess traffic, shaping delays it. Both uses the token bucket algorithm, and everything is controlled using the key terms which I mentioned: CIR, PIR, BC, BE, and TC. So with different policer deciding how, we also discussed like different policers, using different policers, how strictly traffic is handled. So both, as I said, like all these things are essential in QoS design. So if this video helped you understand QoS clearly, please hit the like, subscribe to Networking with Edge, and in the next video we'll look at the configuration. Thank you.